For the different classes in our database, oftentimes we're going to have defining tables. And defining tables are just going to define attributes or what type of data will we find within those classes. So taking a look at our slide here, attributes are data elements that describe the characteristics of instances in a class. The full specification of attributes could be data dictionary, would also include the data type, the default value, constraints on the value such as a minimum or a maximum, or other descriptive information. Attributes include the primary key that uniquely identify instances of the class. Foreign keys that support the links between classes shown in the associations are also seen, and other data elements for each class. Attributes will be specified in a table listing that accompanies each class diagram. Taking a closer look at primary keys, primary keys are an attribute or combination of attributes that are uniquely identifiable for each instance in a class or row of the table. And a primary key, very importantly, cannot be null or blank. Primary keys should be controlled by the organization that assigns it, so it will not change over time. So some things to consider when looking at primary keys, Social Security numbers, probably not the best primary key because not everybody has one, and you can't have a null value. Same with people's names. People's names aren't really unique. You could have 2 Jane Does. Should you use a phone number? No, because that's going to change quite frequently as people change their phone numbers over time. But one thing that is suggested is that you could assign primary keys using sequential numbers, and it is easier to identify gaps and control the numbers. This is another benefit if you do assign them a primary key. Taking a look at foreign keys are attributes or combinations of attributes that allow tables to be linked together. Implements the link between classes and resulting tables shown by the associations. So what we have down below with the person and the relationship being ownership of an auto, this is indicating that these 2 classes should be linked somehow. Okay, and so what we're going to have is possibly a primary key in person is going to have to be a foreign key in auto to create that kind of relationship where we'll be able to link the 2 class tables together. Here we can see a table listing as an example. In this example, customers, orders, order items, inventory, these are all classes. And after those classes, we've got a listing of attributes. So we can see with customers, customer name, you can see this PK in parentheses. That's standing for primary key. So the first attribute here, customer number, is the primary key. All the other attributes being customer name, customer city, state, zip, phone, those are all foreign keys. Looking at orders, here we've got a primary key of order number. And remember that sometimes we can have a primary key that's a combination. So for order items, it's the combination of the order number and the product number that is the primary key. Inventory, we have a product number, okay, which is the primary key. And then following are the foreign keys. Unified modeling language also provides us with other relationship notation, and those being generalization, aggregation, and composition. We'll go into those on the next slide, and this special notation is in a form of shorthand, but each can also be modeled using the basic notation described earlier. So generalization relationships,
allow grouping of things that share common characteristics. It reduces redundancy since the shared characteristics only need to be modeled once. And an example here would be sports cars, sedans, and SUVs could all be summed up into just autos. They have many common elements, such as they have VINs, horsepower, gas mileage, which allows them to have unique characteristics that separately identify them into subtypes. Aggregation relationships describe classes that are often considered together. So although in this example players and teams could exist separately, they are part of a team, and aggregation relationships could be nested. For example, when the team is maybe part of a league. And composition relationships are a form of aggregation, and in this case, however, chapters do not exist separately from books. So I guess that would be one other thing to take into consideration. Here we have 3 other model notations that can be particularly useful in accounting. As described here on screen, we've got a note, which allows the modeler to add an explanation. Role designation is helpful. We can, within the association between the two classes, we can specify a role, and that could be particularly useful, as you see here, where we've got worker or supervisor. Or we could do constraints. They can be modeled with notes, or a constraint can be placed near the constraint end of the association. So here we've got a person can drive an auto, but only with a valid driver's license. So that sums up our section here on defining tables. Thanks for joining me.